So if you are given the solubility, find the KSP. So you'll write out the C, you'll write the KSP. You might have to find the ion concentrations. And because these are all, if you are given solubility, that means it is a dump and stir type problem. Yes? Pardon me? Oh, a data book. I'm so sorry. I forgot about you. Oh, whoops. There you go. Okay, so anytime you are given the solubility, that is dump and stir. Okay? Because it'll say the solubility of calcium hydroxide is 3.8 times 10 to the negative 4 moles per liter. And of course, how would you find the concentration of A and B? Well, if you know the concentration of AB, then you can say it's a 1-to-1-to-1 relationship, yes? You just plug your ions into the KSP and you solve. Now, if you are doing multiple choice, you can just use the formula. KSP is equal to X squared for any AB salt. That's a 1-to-1 ratio salt. If you are doing multiple choice, you can just use KSP is equal to 4X cubed for a 1-to-2 or a 2-to-1 salt. You may not just give these simplified formulas without showing their derivation on the written response. So what it means is you need to write out, normally what you would do is you would say, okay, I have salt AB, solid, in equilibrium with A plus and B minus. And I would have to write my KSP. KSP equals A times B, right? And then I would plug in my concentrations. Let's just say this is 1 molar. I know that it's not going to be 1 molar because that's not a low solubility compound, but let's make it really easy, yes? So that would be 1 molar and 1 molar. So you would plug that in and you would say 1 times 1 . So you would need to show those steps rather than just writing KSP equals X squared and then solving, okay? You need to actually show the KSP expression and the C and the ion concentrations. That's the difference. Not much more work, just a little bit. So let's read through these examples and see if you can tell how this is given the solubility, find the KSP. Read through them. And it's maybe easier to read on your own sheet of paper rather than to try and squint up here at the small print, unless you've got really good eyes. And once you think you've got it, tell your partner how you can tell that this is given solubility, find KSP. I can't tell you that. That's what the question's asking me. So you get to circle which ones are correct. And she's writing it this, saying it in her lab. So you get to circle however many you like, but it might be more than one. But if there's going to be no effect, then that would not be causing it any power. Yeah. Just imagine you have a beaker that's got water and you've got the solution in. Yes? It's got that solution in it. Now you're going to take a spoonful barium nitrate and add it in. And stir it. Oh, okay. Yeah. Thank you. Okay, so first of all, calculate KSP. What is KSP? What is its KSP? But also, there are other kinds of questions where you might have to calculate the KSP. This one says a mass of 0.14 grams just barely dissolves in 100 milliliters. If we're told that it just barely dissolves, what is that? That is, well, it's low solubility, but what else? Pardon me? It means it's saturated. Okay, so if it barely dissolves, that means it is a saturated solution. And if it's a saturated solution, then that is the solubility. In our next question, we have the moles in a liter. And it's a saturated solution. What do we call the moles per liter of a saturated solution? Solubility. Moles per liter of a saturated solution is solubility. So you're given the solubility, find the KSP. In the previous question, you're given the solubility, find KSP. In this one, it's really easy. The solubility is, so you're given the solubility, find KSP. Now, these examples on this worksheet were not ever meant to be assigned as problems, but rather just for you to get familiar with the type of language of each problem. However, over the years, I've had so many students do the problems and request an answer key, so I have provided them. That does not mean you need to do these examples if you don't want to. In the next one, we have, oh, look, we have solubility math problems extra practice. At the end of this one, we have solubility math problems practice. So you don't need to do all the examples within the thing, unless you want to. I mean, I do get people who want to, so I have provided an answer key. Okay, now we're going the other way, type 2. So type 1, given the solubility, find KSP. This one, given the KSP, find the solubility. So we're going backwards. Spot the question. You're looking for words like find the solubility. And what is solubility? Solubility is the concentration of a saturated solution. So if they're asking you for concentration of a saturated solution, they are asking you for solubility. What if they ask you what mass of a salt will dissolve in a given volume of water? So basically they're saying what amount will dissolve in the volume. So this is the maximum amount in the volume. So this is the solubility. What is the concentration of A2 plus in a saturated solution of AB squared? Well, what you would be doing then is you would be finding the concentration of AB2, which is the solubility, right? Because we got a saturated solution, so that's the solubility. And then you would say AB2 gives you 2A plus B minus, and let's say this was X, this would be 2X. Yes? Oh, AB2. I'm so sorry. A2 plus 2B. There we go. Minus. So if you were asked to find the concentration of A, you would find the solubility, and then you'd be able to find the concentration of A just using the stoichiometry. Now here's a tricky one because it uses the word maximum, and people look at it and they're like, oh, that's a maximum problem. It's got the word maximum in it. But you have to think, it's not the maximum of salt A that can be dissolved in a solution of salt B. This one is the maximum amount of salt AB that can be dissolved in a volume of water, not another salt. This is not a maximum minimum problem because we only have one compound here, AB. When we're actually doing maximum minimum problems, we're like, what's the maximum amount of AB that can be dissolved in a 0.1 molar solution of CD? This one is only in water. So for these ones, you need to write a let statement. Let X be the molar solubility of A2B. Do you remember that statement? You get a mark for that. Write the C. Underneath the C, you're going to write the X's. The X's are the concentrations. Write the KSP expression, plug in, solve. Yes? So you need to show all that work for a written response question. Yes? So you'd be like, okay, I got let X be the solubility of AB2. And then you'd say, okay, I got AB2 solid in equilibrium with A2 plus and 2B minus. And then you'd say, okay, I got my solubility is X, so the concentration of A is X, and the concentration of 2B is 2X. And then I would write my KSP. KSP equals A2 plus B minus squared equals X times 2X squared equals 4X cubed, and then you would solve for X. You would have to show all of that. Multiple choice, if you are given the KSP and you have a 1-to-1 salt, you can just take the square root, right? If you have a 1-to-2 salt, you can divide the KSP by 4 and take the cube root. Okay? So I want you to read these questions and see, can you figure out that this is a find the solubility problem? Do they sound like a find the solubility problem to you? It's super easy when it says calculate the molar solubility, right? Or when it says, what is the solubility? But you have to just remember that solubility is a concentration. So if we're asking how many grams per liter, that is a concentration in grams per liter, right? And you could find moles per liter and then go to grams per liter. What is the concentration of OH? Well, you can find the concentration of Zn, OH2 in a saturated solution, right? So those are the clues that this is a type 2 problem. Quite frankly, you don't need to know that it's type 1 if you can just like look at the question and go, oh, this is what I need to do. Nobody's going to be like, is this a type 1 or is this a type 2? It's just, for some people, this is helpful. And I found when I started doing this, people started to be more successful because they started looking at different problems and not trying to apply the wrong tools to the wrong problem, okay? So here we have, you will be given the KSP and you will be given the concentration of one ion or the compound. And then you'll be asked to find the other ion concentration or its compound. So these will almost all contain either the words maximum or minimum or barely begin to precipitate or just start precipitate or without precipitating. These are all mix and match problems. You're going to have two salts, one of which will form a precipitate, which will form a precipitate when you mix them together. So you're looking at a double replacement reaction, right? Now, you are welcome to write the double replacement reaction if you want to. Thank you. If it helps you to identify the precipitate. Yes? However, people get messed up here because they write the double replacement reaction and then they kind of get stuck and they don't remember that they need to write the solubility equilibrium equation for the low solubility compound. Only one of the products will be a solid. Okay, and that solid is going to be the low solubility compound. So the extra step here is to identify the precipitate. This is our precipitate here. Write the C for the precipitate. Write the KSP expression, plug in the KSP and the one ion concentration, solve for the other ion. And if A is equal to 0.1 molar, B does not equal 0.2 molar because B is coming from somewhere else. Okay? So we are told what is the maximum concentration of lead, that's pretty obvious, possible in an 0.1 molar sodium chloride solution. So we have sodium chloride, that's compound A, and then the second compound is lead something, we don't know what it's with, but it doesn't matter. We know that lead is then going to get together with chloride. This one is really tricky, so you might miss it. A saturated solution of SrSO4 has a concentration of SO4 equal to 1 times 10 to the minus 4 molar. What is the concentration of Sr2 plus? Wouldn't it be nice if it was 1 to 1, but it doesn't have to be. Nowhere does it say that they came from the same place. I don't think you're going to get a question like that, though. I think it's highly unlikely. You're much more likely to get a question where you have compound A and we add it to compound B and we have a concentration here, yeah? Compound A, compound B. So it's mix and match, right? Calculate sulfate concentration at the moment precipitate starts to form. If a precipitate is starting to form, that means what is the max concentration of sulfate? Yes? And this last one is easy. The maximum mass of compound A that can be added to whatever of compound B without a precipitate forming. So how many types have we done? This was type 3. Type 4, Q, will a precipitate form? Again, you're going to have 2 compounds or 2 ion concentrations. This is mix and match. So will the ion concentrations be proportional? No. Once again, you'll have to identify the precipitate, find the concentration of the ions, write the solubility equilibrium equation for the precipitate. Now, when it says identify the precipitate, that would be the solid product in a double replacement reaction. Yes? And if you're being asked, does a precipitate form? That is a question. So you're going to use a Q. Not that they aren't all questions, but, right? Yeah, so this one is either, you can call it K trial, you can call it Q, you can call it trial KSP. Yes. Then you can plug the ions into Q and solve. And then you compare Q with KSP. Either it's too small, no precipitate forms, too big, precipitate forms. If Q is equal to KSP, you have a just barely saturated solution and no precipitate will form. Multiple choice, you just don't need to write anything down if you don't want to. Just be aware. Q can be called, we know K trial, we know trial KSP. It can be called the trial ion product. Or it can be called the TIP, which stands for trial ion product. If you're like, I don't know what this is, just think it's probably Q. You can ask me. If you don't remember that, you can ask me on the test. If you're like, what the heck is a TIP? Is someone going to give me some money here for doing this question? That'd be nice. But no, okay. So we have one compound and a second compound, and we mix them, and we are asked, will a precipitate form? Here we have lead and bromide. And then we're being asked, we're not being asked, does a precipitate form? But what we're being asked here is, what will be observed to happen? What could happen? What's the only thing that could happen that would be interesting? I mean, it's not an acid reacting with a base. So you're not going to see, a neutralization. What could happen with these two ions? They could precipitate or not. So don't be freaked out if it just said, what might you observe? Right? You'd be like, maybe I will see a precipitate and maybe I won't. Just depends on how my Q value is. And then again, we have, will a precipitate form? And we're mixing two different ions. And they're not in proportion to each other. Do not multiply anything by 2. Do not divide anything by 2. Just leave those concentrations alone. They are the concentrations. Okay. And the last type of question, type 5, titration. Titration, precipitation. And remember, you need to have a balanced equation. And what type of equation? Balanced, but also a balanced precipitation equation. So is that a one-way arrow or a two-way arrow? One way. Where does your solid go?
On the right.
On the right. And once you have your balanced equation, what's the first thing you do? You find the moles. What's the second thing you do? You find the moles. Okay? You won't be able to find the moles of the second thing until you found the moles of the first thing. You'll be like, what's the only thing I can find moles for? Find that one and then find moles of the other thing. Okay? And most of the time, these will have words in them like titrated, titrated, equivalence point, what was the concentration, that kind of thing. I don't like type 6. I don't think you're going to come across it. This type is so trivial. I've had a hard time coming up with examples, so you won't find any of those in the problem set. You can read through it if you want to, but like I'm not going to stress it. So don't worry about it. And now, why don't you guys try questions 1 through 5? You get to pick which kind they are and see if you can use the correct tools. And remember, if you don't know what to do and it's not a titration, find your solid, write the KSP, write the solubility equilibrium equation. Yeah. Lots of blank paper at the back of the room. Please don't try and cram your answers in there. You won't be able to. If I see anyone trying to write entire things in that little space, maybe I should, like, instead of having a bonus, I could have a negative bonus. Where you lose one on your quiz if you're practicing by trying to cram your writing into that tiny space. Go get yourself a piece of paper if you don't have anything. And I'm going to go to the washroom and grab the answer to the next unit and we can just go ready to start it. What information do you have? Okay. Of. Okay. So you've calculated your volume delivered, have you? Okay. Perfect. Okay. So you have the. Good. Is that the moles or the molarity? Oh, that's the molarity. Okay. Oh, yes, 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 yes. So now, what do you need to find? Find the. Oh, how did you go from this and this to that? What? Okay, what on earth is happening? Okay. I don't even know what's happening here. Let me grab a pen.
I got it.
You got it?
So
Okay.
I times these two.
Okay. Okay.
Later.
Okay, and you multiplied it? You need to actually show that work. Okay, yeah, because otherwise, do you see what happened when I don't know what? I'm like, I don't know how you got it. Yeah. Okay. Titration. So what kind of reaction do you write? Reaction. You can relax. Okay, so when you have milliliters over milliliters, the divide by 1,000 cancels the divide by 1,000. Yeah. If you were, say, doing a titration problem and you want to find moles, and like you want to work with billion moles, right? And you can do that, but most people are like, no, it ain't moles, not what we're gonna do. Then you would have a first field freedom. Okay, yeah. Okay, so it is a titration. So what kind of reaction do you want to write? Precipitation. So who is the precipitate when you mix these two things? AgCl. So you want to write the precipitation reaction for AgCl, right? So that's the first thing you have to do in a titration, is say who is the precipitator. Okay, yeah. Perfect. And this is also the one place where you're not going to be using the KSP, because KSP is for the solubility equilibrium equation. Yeah, yeah, all the others, but not this one. Okay. So when it's titration, you need to find the moles and find the moles. You need to say, okay, what can I find the moles of? Can I find the moles of the Ag, or can I find the moles of chloride? Which one can I find the moles of? Ag. Okay, so you're going to find the moles of Ag, you're going to convert them to Cl. Okay, so that's what you do. You say, what can I find the moles of? Find those moles. You'll use this to say, oh, one of those and one of those, so moles are the same. Okay, yeah. And then you'll say, oh, what am I asked for? What is the concentration? The concentration is moles over liters. Chloride over liters. Okay. Yeah, so work with this. This is your initial burette and your final burette reading. So you're going to have a little extra thing in there. Yeah. Okay. Yeah. Okay. I think that's good. Yeah. Now, one thing you should say, this is moles of Ag plus, right? Or AgNO3. You should also say, oh yeah, but you should also write in here, okay? And you should say that the moles of Cl minus are equal to the moles of AgNO3. That way, you've made that logical step, yes? Yeah. Oh gosh, absolutely, yeah. Yeah.
So.
Oh, I mean, honestly, there's so many different ways to work through this, as long as you know. No, you're fine. No, this is all, we can just do it like all in one line. Oh, yeah.
What's
Is that in this titration, you just spread the solubles or said they made the yeah.
we have M. I got it. Maybe I'll go here. Yeah. So we
Oh, yeah.
so we're good.
So basically what we're doing is we're starting with 15 milliliters of lead nitrate of that concentration. And you can think of it like adding 35 milliliters of water. So if you want to know what the concentration of lead nitrate is, And we need to say, how many moles do I have, which is 50, or sorry, 0.015 liters times 0.05 moles, that's 5 moles. And then you divide by your new volume, which is 50, and 0.05 liters. So when you mix two solutions, you have to do the dilution of your ion concentrations. Okay, and this is just this is like, this is the dilution factor. You remember when we did that? Yeah. Anyway, this is one form of the M1. Yeah. Okay. So what we've got here is we've got V2, or sorry, M2 equals M1 times V1 over. Okay. Yeah. Yeah. That is M1 V1 equals M2. Yes. Yes. Okay. So what we've got is we've got we're mixing two. So in order to figure out what the concentration of the ions are going to be once they're mixed, we have to do the dilution. So it's like you started with 25 mils of lead and you added 35 mils of water. The water happens to contain some other stuff, but it's like you added 35 mils of water. Yeah. It really is. It's exactly what it is. Yeah. Okay. And you can use, if you want to, like this is M. You can think of it as a percentage. I actually like that. But you can say this is M1. Yeah, yeah. Did I see ham somewhere? Whoa. Uh-huh. Oh, that's a typo. Yeah, I'm sorry, but that should be 0.125, not 0.125. Hi, I'm just gonna write down mixed solve problems number 1, 0.125 in key. Okay, yes. Yep. Good. Yep. Perfect. No, you don't do anything with it. You say, this is my concentration. Do not multiply by 2. Yes. Okay. Uh-huh. Oh, and the answers here are wrong. Okay, so that is page 75, number 6. Thank you. Oh, that's already 2 minutes for us. Two. I'm so much for
one had two black.
Oh, I see. Yeah.
Okay, we'll keep you moving, please.
That was good. Good. She told me how long the park. When I come out in the rush, or like during their course, it's like part of the mess. So I like to tell them about like regular kind of 11 is like baby chemistry, right? It's like, you know, you're going for a stroll, Sunday afternoon stroll, yeah, right? And then come 12, you're going on that. And then when you take Chem 11 in Rich, you're like, you know, starting for others, like base down, active oxygen, you know, you got the climbing gear and all the stuff, you know.
We'll take them blending missions to get to see how they all stuff scientists.
Yeah.
Started the class there on that.
Yep.
I remember that.
Yeah. Yeah.
I don't think I was.
Yeah.
Rich.
No. I was called hate now, love me later course. Because hate me now, but when you go to hate university, everyone else is gonna cry. And then they'll be like, oh, I just missed out. Yeah. It's just good. It's just good for your brain, right? And how much else you know, like being upstairs or live, this is how it is. That's true. Oh, it's nice. That's how they're growing up. Number 2 on the check? Yeah, right? Six. Yeah, sorry. Yes. The KSP, you just don't double the concentration. Like if you find the concentration is 0.5 molar, you have to take it up. That's it's still sweating. Sorry. Right. Yeah. In other words, Q. Yeah. Why is it?
I still didn't see you. I didn't do it with this. This is for the.
Yeah, but it would be. Yeah. So you can say, okay. So somebody's gonna give you a sleep about it. Yeah. Okay. So they would always give you all of here and probably or is soluble and if you will form and it gives you a bunch of numbers, you can be like, oh, I'm soluble. Yeah. So I am seeing a lot of people working with their answer key in front of them, which is, yeah, if you're not looking at it, that's good because you want to try it without the answer key first. And if you get stuck, it's better to, like, if we have time, right, if you can call me over, I can help point you in the right direction, right? But if you need an answer key, then doing the quiz is going to suck for you. Do you know what I mean? So you want to see how am I doing at recognizing the problem type? Am I able to choose the right tools? Okay, and especially when you get to doing the extra practice questions for this one, make sure that you're not using the answer key until you very, very, very have to. Okay? And I know you're just sort of starting out on this process, so this is all right. Yeah. Of his given concentrate. Now you need to find a diluted concentrate. Yeah. Yes. So this is what I'm saying is when you're given, often when you're given an acid solving essentially what we've done is you take 50 milliliters of this and you added 35 milliliters of water. Now that water just happens to contain some other stuff, but really we've added some water. So now we have a new concentration, or you can say this big form is that diluted. Does that make sense? Hi. Oh, you need an answer key. Yes, absolutely. There we go.
Oh, yeah. Yeah.
And then when we do part B, we want the solubility equilibrium. Yes. So this is a Q. Will it precipitate form? Will it precipitate form if I mix these two solutions? And it'll give you a bunch of numbers with it, right? Okay, it won't be like a multiple choice, but like, does it precipitate form and you just look here. You know what I mean? But they'll give you a bunch of numbers and you're like, oh, I have to discover if you would do it or not.
Oh, then I don't have to.
Yeah, and we're mixing 15 milliliters of the 25 molar lead nitrate, and we're mixing it with 35 milliliters of other solution. So in essence, what we're doing is we're taking these 15 milliliters and we're adding 35 milliliters of water. Now the water has some stuff in it, but we don't care when this is for the lead. The lead is being diluted. So you're gonna have to do a dilution calculation, figure out the lead concentration in the mix. So you're gonna say, I'm starting with this concentration in 15 milliliters, but I'm finishing with 35 plus 50 milliliters. And one and one and one so this would be M1, M1, and then V2 would be these two added together. And you do the same thing with chloride, and then you can chuck them into your. Okay. No. I mean, you're on the right track. You just haven't been. Yeah. And the direction before you throw them in. Yeah. I'll print out a paper for you. Yeah. I'll be right with you. So, cost supports if you have to make you are it came from and so I should not fail by I said the concentration of biochemicals is 1 mole, 1 mole of biochemicals. In order possible, that you have 2 moles of biochemicals. No, and that's why so much like yes. Yeah. We're dissolving multiplying I3 concentration with fairly light copper iron. Is yeah. Going to such a common thing to do. Such a common thing to do. Okay, so in question 2, the chloride is coming from sodium chloride, yes? So we found that the concentration of chloride was 0.0595 molars chloride, yes? Okay, so imagine that this wasn't 0.0595, wasn't the number was really easy to work with. Say it was 1 molar. Okay, you've got 1 liter, and that contains 1 mole per liter of chloride, so there's 1 mole in here. Is there 2 moles of chloride in there? No, that's why you don't multiply by 2. Okay, now the multiplying by 2, let's say you dissolve lead chloride, you would be multiplying the concentration of lead chloride by 2 to get chloride. You don't multiply the concentration of chloride by 2 to get chloride. Does that make sense? So concentration of chloride does not equal 2 times the concentration of chloride, right? But if it was a dumpy stir, which it's not, then concentration of chloride would equal 2 times the concentration of spread. It's 2 to 1, but it's not 2 chloride to 2 chloride to 1 chloride. It's 2 chloride to 1 of those. Yeah? Yeah. Okay, so it's titration. Have you found? Okay, so the thing we need to do is regular process of doing that. Okay. So you have folks, I want you to finish those 5 questions, and if you have time, please start on the extra practice on the next page. Okay, if you're only able to do those 5, that's okay. But I really want you to get as much practice in between now and Thursday, okay?